Good morning. I guess it's still morning. Super excited to be here. Spoke last year. It's really interesting to me. I haven't been in the crypto mining industry very long. DELV brought me into the crypto mining industry to produce a mining infrastructure product that actually met the electrical code and met the building code. And when I started investigating the crypto mining industry a little bit, what I found was that there was a whole bunch of stuff in this industry that doesn't meet the electrical code, that doesn't meet the building code, that is actually really dangerous. And because of my background, I've been doing nearly 30 years in the electrical equipment manufacturing industry. I just walked around and I'm like, holy cow, how do they get this stuff past the inspectors? And apparently most of the time they don't. People in this industry throw megawatts around like they're popcorn. It's really interesting. I do a lot of work in the oil and gas industry. I do a lot of work in the mining industry. I do a lot of work in the water wastewater industry. A megawatt is a lot of power in any of those industries. Even in the oil and gas industry, a megawatt is a lot of power. And we do about a gigawatt worth of gear a year that we manufacture. So we manufacture a lot of stuff. And people just severely underestimate how dangerous. If you let a megawatt loose, it will kill you. So there's obviously personnel safety. That's your most important concern, right? We don't want to kill somebody. And unfortunately, in this industry, there have been some people killed in mining containers because the egress wasn't appropriate, the fault current management wasn't appropriate, et cetera, et cetera. So we don't want to kill somebody. If you kill somebody, there's a huge liability problem, obviously. And because Bitcoin is becoming more mainstream, there's a significant issue with regard to regulation. If your equipment doesn't meet code, you have the chance of that equipment being red tagged and shut down. I was just talking to a gentleman in the booth who saw some equipment come into the Manitoba area, and they spent more money retrofitting the equipment to get it up to code than they paid for the equipment. So something to pay attention to. So Quality Electrical Systems, we're a Utah-based company. We're a couple hundred people. Like I said, we build about a gigawatt of gear a year. We are an OEM for companies like ABB, Siemens, Eaton. We do a lot of work for Mitsubishi and Toshiba. So we manufacture stuff. You may very well have actually been exposed to some of our equipment and not known it because it had somebody else's label on it. That's exactly the situation here. All of the equipment that I manufacture for the Bitcoin industry has the DELV label on it. I have an exclusive marketing agreement in the Bitcoin industry with DELV and Cryptic. Over a gigawatt, 350,000 square foot facility. We're UL listed, we're ISO certified, we're American Welding certified, and we're certified to build steel structures. So everything that we do is 100% legit and legal. If you look at these terms, fault current, short circuit current, AIC rating, let through current, bus bracing, working clearance, if you don't know what the requirements in all of those categories are for your installation, you need to get somebody involved that does, because this is the stuff that I see just walking around this trade show. This is the places where I see big problems electrical safety wise. Every piece of electrical equipment, if you do an arc flash short circuit study, which is required per the electrical code in almost all installations, there should be a sticker on it like this that tells you how close you can get to that piece of equipment safely. In this, it gives you the arc flash boundary, the incident energy, which tells you how much energy is actually available. If the equipment explodes, how much energy is that explosion actually represent? And then it tells you what the safe working distance from the equipment is. When you look at energy like that, it's really interesting. I saw one the other day that talks about just a 22K arc flash. So if you're talking about a very typical, 480 volt small panel that might be, distribution for a few miners, 22,000 amps of fault current would be a fairly typical fault current for a panel like that. A 22K arc flash is about a 250 kilogram shock wave that goes out from it when it flashes. If you convert that to pounds, that's somewhere in the neighborhood of 500. That's about the force that a prize fighter can punch with. So that arc flash is about like getting hit in the face by Mike Tyson. When you look at a one-line diagram, this is a pretty simple one. The size of your transformer is basically what dictates how much arc flash you have. A good rule of thumb is that the transformer, whatever the full load current on the transformer is, so if your transformer is capable of producing 2,000 amps of full load current, the transformer is capable of producing approximately 18 to 20 times that much fault current. So if you've got a transformer that can produce 2,000 amps to feed your miners, which is approximately 1 megawatt worth of miners, you are looking at something that can produce 40,000 plus amps of fault current. So if a 22K fault is like getting hit in the face by Mike Tyson, a 40,000 amp fault, just the shock wave alone, not the arc flash, not the burn, just the shock wave alone is potentially lethal. So basically, transformer creates the fault current. You've got circuit breakers or fuses in almost everything that I've seen. Those are what limit the fault current. Fuses are really, really good at limiting fault current because they're much faster than breakers. So when you have a short, the fuse can actually blow so fast that as the current starts to rise, the fuse can blow before you get all the way to the fault current level. This is what they call a let-through curve, and significantly helps you to improve the safety in your mining. So with our system, you've got a fuse and a breaker in series to give you maximum protection. So this module plugs into our shelving system. There's actually bus work through the shelving system, so all of the power distribution is handled right in the shelving system. We call it power distribution shelving. We were actually able to obtain a patent on the idea of burying the bus work in the shelving. So what we're really interested in, and what we would just love you to stop by the booth 75 and talk about, is, what are you doing in your facility? How are you addressing fault current concerns? How are you addressing arc flash concerns? Is your equipment UL listed? Does your equipment have appropriate aisle spacing? Does it have appropriate, arc flash studies done on it? Is it stickered? Is it legal? We just really want to be the leader in the industry as far as making sure that the equipment that you put out there is safe, that the personnel that are operating that equipment are safe, that the equipment, well-designed equipment that's safe is also a lot more reliable. So it will improve the reliability of your operation. And we're just really excited to be here this year. Really excited to have you guys stop by, and let's talk about what it takes to keep everybody safe and our equipment running reliably. Thank you.